Okay, hello everyone. Welcome back to our P4 competition DMD. And this week we are going to talk about the solutions for our week 5 DMD. Now, without further ado, as usual, I'm teacher ChiYew, and let us begin on the first question. So, the seat number of a theatre is composed of an English letter followed by a number. Given that we have 26 letters and 48 numbers, what is the maximum number of seats in the theatre? Well, so in this case over here, we have a number. Alright, we have a letter and then we have a number. So we are going to kind of apply our multiplication principle again. Right. In this case over here, we need an English letter first. So how many letters are there? Well, we have 26 letters. And how many numbers we can use for the next portion? Well, 48, right? So I guess you guys are pretty much used to it by now. You guys have been following the DMD. So total number of ways is really just by our multiplication principle. It's just going to be 26 times 48, which will give us a very nice grand total of 1,248. So I hope this question gives everyone a good review on what the multiplication principle is about. Now, without further ado, let's move on to the next portion. So there are 6 individuals which standing in a row. If Mike only wants to stand in one of the 2 middle positions, there are how many ways to stand? So I'm not sure what are the 2 middle positions. That's the thing. So we have 6 students, but we are for sure that he only has 2 positions that he would like to pick in this case. So maybe, just maybe, without any loss of generality, he picks this portion. So there are 2 ways for him. That's the idea of the multiplication principle. We are applying the multiplication principle again. And what about the rest? Well, the rest, the second person will have 5. Maybe he stands here. Third person will have 4 ways, followed by 3, followed by 2, followed by 1. And by our multiplication principle again, the total ways is just going to be 2 times 5 factorial. So some of you guys know what is the factorial notation, which is 2 times 5 times 4 times 3 times 2 times 1. And this is going to give us a final answer of 240. Yep. That's pretty much about it. So this one is a good review on the multiplication principle. Even though we know that we are not sure where Mike stands exactly, where does he exactly stand at, we are for sure that he only has 2 ways. So we can draw the diagram. Hey, just imagine that Mike is standing at any one of the 2 seats that is supposedly allocated to him. So that's the main idea. That's how powerful the multiplication principle is. As long as we know the number of choices, we can simply multiply them up together. Alright, I hope this one is clear. Now let's move on to question 3. So Amy and Ben started from town A. And then we have Charlie started from town B at the same time. So when Amy and Charlie met, Ben had just walked 1/3 of the entire journey. At this moment, Amy immediately turned around and walked towards town A, while Ben and Charlie continued to walk in the same direction. When Amy and Ben met, Charlie was 335 meters away from town B, and the 3 people continued to walk. When Ben and Charlie met, Amy just returned to town A. How long is the distance between the 2 towns? So it looks a little bit complicated, looks a little bit confusing, but not to worry, let's take a look. And it can be actually simplified by drawing out the little diagrams, a few diagrams over here, a little bit distance diagrams for us. So let's draw out. So we have town A, those are town B. So let's see, Amy and Charlie has met. So let's take a look, maybe A and C is somewhere along this line. So we know that Ben has traveled 1/3. That's the main idea. Now, we are going to skip the 335 meters part for now. Look at the way Ben and Charlie has met. when Ben and Charlie actually met, we noticed something. When Ben and Charlie had met in the same place, Amy has just reached back town A. So it is actually very fair for me to immediately see that this is actually 2/3. Why? Because of proportionality. When Amy has met Charlie, that acts as a stopping point. Ben has traveled 1/3. And Amy has to travel back the same distance that he has previously traveled. So what does that mean? That means that when Amy reaches back town A from Charlie, Ben must clear 2/3 of the distance. And hence, this immediately implies that Charlie actually cleared 1/3 of the distance. Now, since by proportionality again, we know that Charlie actually completed 1 out of 6 of the distance over here, and actually Amy has cleared 5 out of 6 of the full distance. So let's take a look at the ratio of their speeds now, alright? Ratio of their speeds now, just going to be 5 over 6 is to 1/3 is to 1 over 6. And we don't really like fractions, right? So we are going to simplify this a little bit. We are going to 5 is to 2 is to 1. That's the main idea behind this. So let's take a look now. The next very important component that we'll look at is this. When Amy and Ben met, Charlie was 335 meters away from town B. So we're going to use a little bit of their ratios of their speed over here. So we know that Amy and Ben has met over there, and Charlie was 335 meters away from town B in this case. So what is the speed of Ben? That's the question. What will be the speed of Ben if that is the case? How much has he actually completed? Well, let's take a look. So when Amy and Ben has met, they in total has completed 5 over 6 times 2 of the complete distance. But by proportion, let's take a look. A is to B is really just 5 is to 2. So technically speaking, out of this whole distance, Ben has only cleared 2 out of 7 of the complete distance. Because 7 units, right? Ben has only done 2 units. That is the main issue. So by simplifying this, you clear 10 out of 21. And we notice that Ben's speed is double Charlie's speed. So Charlie's speed, Charlie will clear only 5 out of 21. And this is equivalent to 335 meters. So by simplifying, we can immediately figure out that the complete distance is actually just 5 over 21. Sorry. It will just be 335 divided by 5 over 21, in which we'll get 1407 meters. Now that's the main idea. So the whole idea is to understand the concept of proportions and be able to infer proportions from this question over here. That's the key idea for this. Alright, so let's move on to question 4 now. Let's see question 4. It takes 10 hours to travel downstream and 15 hours to travel upstream between 2 ports, which are 180 kilometers apart. If the water speed increases after a storm, it only takes 9 hours to travel downstream. How many hours will it take to travel upstream after a storm? So let's do a little bit of illustration over here. We have 2 different ports. Alright, of course they are 180 kilometers. So we have a boat. A boat has a standard speed. And then we have water pushing it downwards, right? And then for downstream, we also have water pushing it downwards. Now that's the main idea and concept behind this. We are looking at the effective speeds, right? We need to add these 2 things up and we need to try and isolate them. Now, so clearly you guys can see the speed of the boat is actually, you guys know this, you just be taking both timings, travel downstream and travel upstream, take the speeds of both of them, add them up, and we divide it by 2. That's the main concept, because we want the speed of the water to cancel out. And that's the main idea that we are going to go. So it will be half 180 divided by 10 plus 180 divided by 15. This one is just going to give us 15 kilometers per hour. That's the speed of the boat. Now, what about the speed of the water, at least before the storm? Well, the same logic applies. We are going to, this time round, we are going to subtract instead, if you guys notice. It will be half 180 over 10 downstream and then upstream. Alright, so this one is going to give us 3 kilometers per hour. So after that, after the rain, of course, after the storm itself, speed of water. Now you guys notice the speed of water after the storm is going to be a little bit different. Well, if you look at it carefully, it only takes 9 hours to travel downstream. So we're going to take a downstream speed, subtract away the boat speed. So it will be 180 divided by 9. And then I'll subtract away 15. And that will give me 5 kilometers per hour. That is the speed of water after the storm. And so we have gotten that. And that's really good. It's going to be very helpful. And of course, now, when we are to travel upstream, we are going to face some resistance, right? So maybe I'll use the little space over here. Speed of boat upstream, right? It's just going to be 180. Now, the speed of the boat is 15. But we have to subtract away 5 because of the water going downwards. So it'll be 15 minus 5. Sorry, this one is time taken. Time. Alright, this one is going to give us just 18 hours. So the whole idea and concept of this question 4 is to be able to understand that water speeds, in the difference between effective speeds and normal speeds. We know the speed of the boat. But what is the true effective speed? In this case over here, the speed of the boat upstream is effective speed of the boat upstream is just 10 kilometers per hour. The boat is traveling at 15. But because of the water going downstream, going against it, we have an effective speed of 10 rather than 15. That's the main concept and idea behind this question. So now let's move on to question 5. So of course, we can see car A and car B started from 2 towns and start a drive towards each other. When car A traveled 80 km, car B traveled 10% of the entire journey. When car B reached 5/8 of the entire journey, car A reached 5/6 of the entire journey. What is the distance between the 2 towns? Well, I guess we can immediately see the ratio over here between A to B is actually just 5/6 is to 5/8. Simplifying, it will just be 4:3. That is the key concept behind this. So let's take a look. When car A has traveled for 80 kilometers, car B has traveled 80 multiplied by 3/4. That's the main idea. And then we're just going to get 60 over here, 60 km. So when car A traveled 80 km, car B has traveled 60 km. So what's the distance between the 2 towns? Well, we know that car B has traveled 10% of the entire journey. So distance will just be equal to 60 times 10, which will give us a 600 kilometers. So that's the idea, identifying important ratios over here and be able to understand the same proportion. So this one is very similar to our question 3 over here. Alright, I hope this one is clear enough. Now let's move on to the next question. Now, if the points M and N are midpoints of the sides of a square and the shaded region is 60 cm squared, what's the area of the rectangle? So it looks very interesting. There must be some way that we can use the concept of midpoints over here. And there is. we can cut it out. Alright, whenever we are not sure how this thing works, we can always cut it out in this fashion. So maybe I'll just draw out this line over here. Maybe I'll draw this line over here. Alright, we notice a little bit of things. We can transfer this purple piece to this red piece, and this purple piece, this red piece from this purple piece. And we will immediately notice that 3 out of 8 of, so we can use 1/4 plus 1 out of 8, which is equal to 3 out of 8 of square is shaded. Right. So in this case over here, we can immediately see that 3 out of 8 of the square is shaded. And think about it. If we look at it a little bit more closely, how many squares, or rather, how many triangles? Notice that how many big triangles? Which big triangles over here, how many of them are actually shaded? Because we are focused on the fact that the areas are the same for each of them. So one triangle is actually equal to 60 divided by 3, which is equal to 20 cm square each. Now we are going to really count them all out now, right? We have 1, 2, well, we have a 3, 4 here. We also have 5, 6 here, 7, 8, 9, 10, 11. Is that it? 10, 11. We still have another part over here, right? This one is actually half of the whole triangle. But because both of them are together, we actually have 12 triangles in total. So we can immediately see that the total area is actually just 12 times 20, giving us a grand total of 240 cm squared. Now, so the concept for this question is not difficult, but it is actually more about being able to reorganize the whole picture when we are given very limited information. But of course, the whole idea requires the concept of midpoints in order to help us out. Otherwise, we won't be able to do it. So let's move on to the last question for the day, another geometry question. So two circles centered at O1, O2 have radius 1 cm. Now if the shaded regions have the same area, find the area of rectangle AB O2, O1. Well, it looks a little bit difficult at first, but the good thing is the shaded regions have the same area. So we can do a little bit of manipulation. Now let's take a look. Maybe I'll just draw something like this. Can you see that this region and this region is equal? Right. They both must be the same. So I will transfer it there for the rectangle. And what about this one? I noticed that this purple region is the same as this region by the question. Those regions have the shaded area. So you notice that it becomes really nice. The rectangle, the area of the rectangle is simply just half of the square, half of the semicircle. So the area is just going to be, pi r squared divided by 2, right? That's going to be half pi r squared. But what is r? We have 1, right? It's just going to be half pi. And half pi will just give us a final answer of half times 3.14, which is equal to 1.57. And that's the main idea for question 7. So with this over here, this question really requires us to piece things out together instead of finding things by brute force, because it's going to be extremely difficult finding by brute force. They have given you a hint. They have the regions having the same area, and that is the whole idea behind this. Alright, so with that, that is about it for our week 5 DMD. And do keep a lookout for our week 6 DMD as usual, and attempt out the questions, and as usual, I'll be going through the solutions next week. So with that, thank you very much and have a good day ahead.